Hey, this is Mr. Kelly Baumholder. We're looking at a section 11.4, chord secants and tangents, the last section for circles. I'm going to start you off with a little contest, trivia, shall we say. Check this out. Remember this?
How about if we win, they have to get rid of the rooster? Ooh, that's interesting.
If you win, give up the dust. But if we win, we get your apartment. Ooh.
Deal!
Wow, that's interesting. We're going to see how that works out for Joey and Chandler later. We're going to start by learning a theorem about two chords on the inside of a circle. All right, so the theorem says that the measure of an angle formed by two chords that intersect on the inside of the circle. All right, so it's basically you draw an X on the inside of a circle. There's one, there's the other. The measure of that angle is equal to half the sum of the measures of the intercepted arcs. So what does that mean? That means that I'm going to call this angle X. In the circle on the left, X would equal 1/2 the measures of this arc here and this arc here, because those are the two arcs that are intercepted. So in this case, it is 70 plus 50. Okay, so X is going to equal half of, we'll say 120, call it 60 degrees, and we're done with that one. All right, can we look at the next example? What do we have? Here's the angle, 125, so you have to look at where the arcs are intercepted. So what do we got? We have this arc here, and we have this arc down here. So remember, the angle formed at the chords is half the measure. All right, so I'm going to write it out that way. Let's do the angle, which is 125. 125 is half the measure of the sum. So you have to add those two together. So we're going to get 8x plus 1. That's the first angle. Second one is 185. So we're going to add them all together. Let's combine some like terms. All right, let's get 8x plus 186. Can we distribute? Everybody loves to distribute. All right, we're going to get 4x plus 93. If I subtract 93 from each side, what do we get? 32. We're going to get 32 equals 4x and x equals 8. All right, so hopefully the algebra is not a problem for you because we're going through this pretty quickly. Make sure you pause the video if you need to so you can get this all written down. Let's try 2 by yourself. Pause the video and we'll see how you do. Go. All right, hopefully you were honest. You worked through these problems all by yourself. In the first one, let's set it up. So 115 equals 1/2 of 100 plus x. All right, or x plus 100. I then distribute. You get 50 here. Subtract 50 from each side. How do you get rid of a half x? Times 2 each side, you get 130 for that one. So that one's pretty easy if you know your algebra. Second one, 10x minus 2 is equal to half of 156 plus 60. That simplifies to 216. You can multiply that by half and get 108. Add 12 to both sides, 120. Divide by 10 to get x equals 12. So this is one of the more easy theorems that you're going to come across. If the two chords intersect on the inside of the circle, it's equal to half the sum of the intercepted arcs. Easy enough. So now we need to define what a secant line is. Now, before we've seen tangent lines. Remember tangent? That was section 1. Here's a tangent line. It's a line that's on the exterior of a circle that it only touches in one place. Okay, a secant line touches in 2 places. Okay, so the definition is a secant line is a line that intersects a circle in 2 points. It goes right through the circle. Okay, that's a secant line. This is a secant line, if it's a line. That's a secant line. That's a secant line. Okay, so those are all secant lines. The next theorem deals with secant lines or tangents. Let's take a read at it. The measure of an angle formed by 2 secants, 2 tangents, or a secant and a tangent drawn from an external point. Okay, so some point outside the circle is equal to half the difference. All right, so in the last theorem, you had to add the 2 arcs. This is half the difference of the measures of the intercepted arcs. So let's see how that works. All right, so what do we have here? In the first example, we have 2 secants. They go through the circle, and they both intersect twice. So remember, the measure of this angle out here at this external point, I'm going to call it x. I don't like question mark. So x is going to equal 1/2 the difference. You need to subtract, and you have to subtract the smaller angle from the larger angle. So in this case, you can't end up with negatives. If you end up with negatives, you done messed up. Okay, so x is going to equal 1/2. What do we get, 90 for this? What's half of 90? Let's call it 45 and be done with this problem. Everybody get it? Let's do the next one. I don't know what this is out here. I'm going to put a little x. Here we have a tangent and a secant line. All right, it's the same theorem. It's hard to screw this up. So 58, the angle on the outside, 58 is going to equal 1/2 the difference. So which one of these is larger? The x is larger. You can tell by looking at it. So it's going to be 1/2 x minus 89. You always want to subtract the smaller arc. All right, so now what can we do? Here's a little trick. I'm going to multiply both sides by 2, and the reason why, I don't want to deal with that half. I just hate half. So this is going to give me 1/16, and that half and that 2 will cancel, so I'll just have equals x minus 89. Now if I add 89 to each side, we can do that, plus 89. Okay, 216, 206, 205 equals x. See what I did there in my head? See what I did? So the measure of this angle here, or this arc, sorry, is 205 degrees. Easy enough. Two tangents now. Look, they don't even give you anything. How are you supposed to figure that out? 50 degrees, they don't even give you anything but this little arc right here. Let's change that color. So what do we have? We're going to call that x. Well, if that's x, what's this arc right here? The long way around. Well, the two arcs make up the whole circle. So if they make up the whole circle, the two arcs add to 360 degrees. So if I call this arc angle x, then I can call this arc out here 360 minus x. I don't know what it is, but it's 360 degrees minus x. So let's use those two measures. Look, we have an x and we have 360 minus x, and let's write an equation and see if we can solve it. All right, so here we go. 50 is going to equal 1/2 the difference. So let's make sure we do this properly. The difference would be 360 minus x, and then you subtract x minus x again. Everybody see what I did there? This part is here, and this smaller arc is there. All right, that's the difference of the two arcs. I'm just subtracting them. So what do we get? 50 equals 1/2. I'm just going to combine like terms first. Negative x and a negative x is a negative 2x, so we have a minus 2x. I'll distribute the half. Fine, I'll distribute the half. I like to multiply both sides by 2, but here, whatever. Okay, so I distribute the half. I get 50 equals 180 minus x. If I subtract 180 from each side, see how this one's a little more algebra? What are we going to get there? I'm going to get negative 130 equals negative x. All right, we divide by negative 1, and we're going to get 130. So x is going to equal 130. What is the other angle here? That would have to be what? You subtract 130 from it. So the answer to the question is 130 degrees. But the other arc, if they do ask us, is 360 minus 130, which would be 230 degrees, which is larger than 130. So everything works out. That works awesome. Why don't you try the next 3 all by yourself? Pause the video, work them out, be honest. All right, so I didn't do the third one yet because I want to emphasize something that I think some of you might have a trouble with. So we'll do that one together. But for the first one, you have to find this arc first. All right, so 360 minus 250 is 110. You put in the equation, the angle equals half the difference. You work it all out, you get x equals 6. Cha-ching! That one's easy enough. Next one. What do we have here? 18 minus 6 minus 114. So that's what I put. That is the difference right here. That's what the angle is equal to, half the difference of the two arcs. So when you work it all out, you get x equals 11. Cha-ching! All right, now the third one, what I'm going to do is I'm going to clear the board. So pause the video if you need to copy these down a little bit. Hopefully you worked it out yourself. Let's clear the board. So 7x plus 7 is going to equal half the difference. All right, so the larger angle is 139 minus the smaller angle. But you can't just write minus 16x plus 5 like this, because that's only going to subtract the 16x. It's not going to subtract the whole angle. So you need to include parentheses. So this is the tricky part I wanted to emphasize. If you're doing 139 minus this whole angle, make sure you subtract the entire angle, and you're going to need parentheses there. So this is kind of ugly, so let's simplify it. Let's see. Let's just leave everything and distribute that negative. That negative's got to go to both. So it's minus 16x and minus 5. That's going to make a big difference here. So 7x plus 7 is going to equal 1/2. What do we get? 139 minus 5. That's going to be 134 minus 16x. I'm going to distribute that half now. I like that because they're both even, so that'll work out nicely for us. So what do we get here? 65, 67. So we get 67 and then minus 8x. So how do we solve this? This is a very, very simple Algebra 1 problem. Let's add 8x to both sides. Put that right there. Draw a line. 15x plus 7 equals 67. If I subtract 7 from both sides, 15x will equal 60. X will equal 4. So we're done with that one. All right, so I just wanted to emphasize with that last one that when you subtract, you have to subtract the entire angle, so put that in parentheses. I think we need some more trivia here. Help us out through this this long lesson. Here we go.
What was Monica's nickname when she was a field hockey goalie?
Big fat goalie.
Correct. Rachel claims this is her favorite movie.
Dangerous Liaisons.
Correct. Her actual favorite movie is...
Weekend at Bernie's.
Correct. Monica categorizes her towels. How many categories are there?
Everyday use.
Fancy.
Guest.
Fancy guest.
2 seconds. 11? 11. Unbelievable. 11 is correct.
See how Joey did that? Pulls a number out of nowhere? Sometimes I think that's how Bruss got through college. All right, so the first theorem. If two secants are drawn from an external point to a circle, the products of the lengths of one secant segment and its external segment equals the products of the lengths of the other secant segment and its external segment. Say what? All right, so what does that mean? That means that if you take the entire secant times the external segment, it's the part on the outside, it's going to equal any other secant times its external, as long as they're coming from the same point. So the way I can write this out using variables is we have a times the entire secant, a plus b, is going to equal c times c plus d. All right? So we're going to see what that looks like with numbers here in a few minutes. Let's look at the next theorem. If a tangent and a secant are drawn from an external point to a circle, it's basically the same theorem. One of them is a tangent now. It's not a... we have a tangent, not two secants. We have one secant and a tangent. So what does that look like? The products of the lengths of one secant segment and its external segment. So here's the secant segment and its external. So a times a plus b again is going to equal the square of the length of the tangent. So here that equals c squared. So let's see how that's applied to different problems. First problem, we have two secants. So I need to find, we have the external pieces, the 8 and the 7. And we need to find the length of the entire secant. So for the first one, it's going to be 8 times the entire secant, which is x plus 8. That's going to be equal to 7 times the entire secant, which would be 7 plus 9. Okay, so hopefully you can go through this. We get 8x. I'll distribute here. Plus 64 is going to equal, what do we get? Well, you can distribute if you want to, but why don't we just add those together? 7 times 16. So what is 7 times 16? 7 times 16 is, what do we get? 7 times 8 is 56, so 112 would be 7 times 16. See what I did there? Subtract 64 from each side. Okay, if I subtract 64, I get 48, and then x here would equal 6. Easy enough, huh? Okay, second example here. Remember we have to do, when we have a tangent and a secant line. So let's look at the secant first. It's the length of the external segment times the entire secant. All right, so that's going to give us 27 times, what do we have here? X plus 27. X plus 27 is going to equal the length of the tangent squared. So that's going to equal 36 squared. So now it's just a matter of doing a little math here. What do we got? Distributive property, 27x plus 27 times 27, 729. 729 equals 1,296. Sorry, I had to do that in my head here. Getting a little confused. We get 27x, subtract 729 from each side. We get 567. Divide by 27. X is going to equal 21 for that one. Easy enough. Okay, the next two are for you. Pause the video. Do the next two all by yourself. Go. All right, let's focus in on these two right here. Hopefully you did okay. For the first one, we have a tangent and a secant. So remember, it's the external. Let's get out that highlighter here. The external part times the entire secant. So it's 16 times x plus 16 equals the tangent squared, the other piece squared, equals 20 squared. Work it all out. You should get x equals 9. And for the last one, you have two secants. It's the external part times the entire secant. So that's 10 times x plus 10 equals 9 times external times the entire, which would be 20. Okay, you can just add those together, work out a little algebra, you get x equals 8 for that one. So, hey, those are those examples. Let's do a little more friends.
Joey had an imaginary childhood friend. His name was...
Maurice.
Correct. His profession was...
Oh, Space Cowboy!
Correct. What is Chandler Bing's job?
Oh, gosh!
10 seconds. You need this or you lose the game.
It has something to do with transponding. Oh, he's a transponster! That's not even a word!
Okay, last theorem here, theorem number 5. This is so easy that Sully and Bruss can do it. I'm serious. You got to be pretty easy. If two chords intersect inside a circle, the products of the lengths of the segments of one chord is equal to the products of the lengths of the other chord. So we have A times B, that's the product, is going to be equal to C times D. It is that simple. You take the two pieces, you multiply it. You multiply the same. It has to be the same chord, okay? But the different parts that are being intersected here, we have this segment and that segment. Those two segments being multiplied, the product of that will equal the product of the other two. So, how easy is this to work out? Well, you're going to be given a circle like this. You just have to multiply, and I always make sure that I do it so that you have the coefficient and the variable, so 12 times x equals 10 times 6. Now I'll write it out just so we know what's going on. But you're going to get 12x equals, what do you get, 60? X equals 5. I told you it was easy, and I was mildly serious. That is serious. Let's do the next one. 10x equals, what do you get, 16 times 15. So 15 times 16 is going to give us a 240. Divide by 10, we get x equals 24. Seriously? That easy? Billy Ray's serious. Last one, do it yourself. Ready, go. This was so easy I didn't even have to work it out. 8x equals 10 times 12. 10 times 12 is 120. I do 120 divided by 8, I get 15. It is that simple. Hey, that's it for circles. There's a lot of stuff. You just got to practice it so you know when to use what theorem, so on and so forth. Let's end it with some of that Friends trivia. This is Mr. Kelly and Baumholder. Remember, it's nice to be important. It's more important to be nice.
You know what? You are mean boys who are just being mean.
Hey, don't get mad at us. No one forced you to raise the stakes.
That is not true. She did. She forced me.
Hey, we'd still be living here if you hadn't gotten the question wrong.
That was a stupid, unfair question.
Don't blame the questions.
Would you all stop yelling in our apartment? You are ruining moving date for us.